Hello, my beloved ones. Today, let's add some variety to our character's arsenal. The first thing we need to do is add a new variable to our character. Let's select it, go to the object properties, add a variable of type string, and rename it to weapon type. Assign the default value, gun. We will have three types of firearms. The first type is the regular one, where a single bullet flies in the chosen direction. The second type is a shotgun, which shoots 3 bullets. And the third type shoots 8 bullets in all directions. Currently, in the player shoot branch, the weapon type is not taken into account during shooting. Now, we need to spawn bullets in different ways, depending on the value of the weapon type variable. For convenience, let's cut this connection. Highlight all blocks responsible for shooting and move them somewhere else. Connect them to a new block, a function. Let's name the function gun. Now we can call this function using the call function block. Connect it to the old place and enter the name of the function to be called gun. It is also necessary to specify in which logical branch this function is located. Connect the self trait block to the trait channel. This means it is in the character's own branch. Now we have returned to where we started. But our main code looks more compact. All direction checks and bullet spawns are neatly packed into one block. For better visibility, let's switch to the Node tab in the right panel and add a label to the new block. For example, gun. Also, let's color it yellow. We can agree to use the yellow color for functions. We can run the game and check if everything is working, if nothing is broken. And now, let's simply add a gate block right after the timer. And check the value of the weapon type variable. For gun. Now, the gun function will only trigger if the character is holding a regular gun. Let's organize it neatly. Put the condition in a green frame and label it. Copy the condition, place it below, and connect it to the false channel of the first check. Change the value in the string block to shotgun. Also change the label on the frame. Now we have a fork with two options. If the character is holding a regular gun, then the gun function is called. If not, the false channel is triggered, and the next check is initiated. In this check, we verify whether we currently have a shotgun in hand. If it's true, the true channel is activated. We will connect the shotgun shooting mechanics to this channel, packed into a similar function. But we will do that a bit later. First, let's add the shotgun crate to the screen. To do this, go to the box spawn branch and spawn a crate, named box shotgun. Use the same random coordinates for the spawn. Start the game and make sure that the shotgun crate appears among the others. Return to the scene, select the crate, and check the value of the bonus type variable in the object properties. We need this value to correspond to reality. Enter shotgun there. Now we need to set up the activation of this crate. For this, navigate to the box activate branch. Copy the frame with the condition. Place it below. Sequentially connect it to the last false channel. Change the checked value to shotgun. Now, if it happened that we activated the shotgun crate, we should change the value of the weapon type variable to shotgun. Then remove the activated crate from the inventory, set a timer for 6 seconds, and then reset the value back to the default, which is gun. Don't forget to connect the crate's name block to the remove object block, or you'll remove the character. Also connect it to the conditions object block, otherwise, we won't be able to activate the crate because we will be looking for the variable in the character's pocket. Now, let's check the functionality of the scheme. Start the game. Shoot with the regular weapon. Grab the shotgun crate, activate it, and see that we lose the ability to shoot for a whole 6 seconds. After the timer, we regain the ability to shoot with the regular weapon. Now, we just need to implement the shotgun physics. Go to the player shoot branch, copy the gun function call, and connect the copy to the second condition. Change the function name to shotgun. Now we need to create the body of this function. Move to the code of the first function, select it, copy it, and place it to the right. In the function block, write the new name, shotgun. Now, let's navigate the code. We have 8 places where we spawn bullets. The spawning mechanism is the same. We specify the desired location and rotation angle using the getObjectTransform block, where we indicate the necessary spawn point. And now, we need to spawn 3 bullets at once. To do this, we'll use a loop with a counter. Retrieve the loop block. Set the range from 0 to 3. We have 3 bullets, but they will spawn in the same place and be rotated in the same direction, making them look like one. We need to rotate all bullets at different angles. The first bullet will rotate counterclockwise by 15 degrees, the second will fly straight, and the third will rotate clockwise by 15 degrees. We'll use the index channel for this. It passes the current index of the loop iteration. If we multiply it by 15, we'll get 0 on the first iteration, 15 on the second, and 30 on the third. Now we can use these values to rotate each bullet by 15 degrees more than the previous one. However, we need to add these values to the current direction, of which we have a total of 8. So, let's get another math block and add the obtained value to the current rotation angle of the spawn point. We can get this angle using the combination of getObjectRotation and separate-rotation blocks. Specify the object for spawning. Currently, we are adjusting the shooting on pressing the up arrow key, so we need to specify the object, spawn point F. We can copy it from the getObjectTransform block. Now, let's switch from radians to degrees and isolate the z-axis from the vector. Since we will only rotate the bullet along the z-axis, we need to add an offset of 15 degrees to this z-axis value. Connect it to the second channel of the addition block. Now, we need to somehow pass this calculated rotation angle to the bullet. We need to replace the unnecessary block, getObjectTransform, with the transform block. Connect the rotation block to the rotation channel. Now, we have the ability to pass the rotation angle to the bullet. Change the mode to axis angle, degree. Set 1 in the z-axis. Connect our calculations to the angle channel. The last thing left to specify is the coordinates for spawning. Retrieve the getObjectLocation block. Specify the same spawn point in it and connect it to the location channel. If we run the game and activate the shotgun, we will see that the bullets fly not straight, but with a counterclockwise offset. This happens because a rotation of 0 was added to the first bullet, we added 15 to the second, and 30 to the third. We need to align this range by rotating all bullets by 15 degrees clockwise. in the negative direction. So, add another math block and subtract 15 from the calculated angle. Now the bullets fly symmetrically. Now we need to copy this mechanics to all other directions. But first, let's organize the new code section. Highlight the 3 blocks from which we read the spawn point angle along the z-axis and add a blue frame with the name get angle to them. Let's highlight the 3 math blocks. Add a red frame with the name correct angle to them. Combine the last 3 blocks responsible for transformations into a blue frame named set transform. Now select these 3 frames along with the loop block. Press Shift-D to copy them. Immediately press Alt-P to detach the copied blocks from the current frame and drag them into the next frame. Connect the loop block between the check and spawn. Connect the transform to the transform channel. Copy the name of the spawn point and paste it into 2 blocks, get rotation and get location. After this, the get transform block can be deleted. Repeat this procedure 6 more times. And with hope, start the game. Grab the shotgun, check all 8 directions. If the bullets fly in the right direction and in the correct quantity, then it's time to relax. If any of the directions are not working or working incorrectly, then go back to the code and find the error. Take care of yourself. See you soon. Goodbye.